Alternating current is one of two forms of electricity that we use in our everyday lives. AC has special properties which allow the voltages and currents to change the direction of flow, and when graphed looks very similar to a sine wave from trigonometry, which looks like this. Now, AC voltage and current have a waveform that is exactly the same as this sine waveform, allowing us to deduct many characteristics about how AC works. Some simple terminology that we use when working with AC waves are terms such as a wave's period. The period or cycle of the wave can be said to be the time it takes for the wave to perform a full loop of 360 degrees. Another term commonly used is peak voltage, which is essentially the amplitude of the wave. Each period of the wave reaches two peak voltages, one that is positive and one that is negative. The voltage difference between these two peaks would be referring to another term called peak-to-peak voltage, which is essentially double the voltage peak value. As shown here, the voltage peak would be 10 volts, therefore the peak-to-peak voltage would be 20 volts. The RMS voltage is essentially the equivalent DC voltage, also known as the effective voltage. This is determined by dividing the peak voltage by the square root of 2, or 0.707. We can determine this value mathematically or use tools such as a function generator and oscilloscopes, which alongside the RMS value can also be used to determine an AC wave's precise period, frequency, or voltage peaks using divisions and scales. An AC wave can be written and expressed with the formula Vt equals A sine 2 pi Ft plus theta, where A is the amplitude of the wave, F is the frequency in hertz, and theta is the phase. Phases are the shift along the x-axis when a wave leads or lags behind another wave. To determine the phase shift, a formula of theta is equal to d2 over d1 times 360 degrees is used. For example, the two waves shown can be expressed as having d2 is equal to 0.6 of a division and d1 is equal to 5 divisions. Therefore, using our formula, we can deduct that the phase difference is 43.2 degrees. These are the basic characteristics of an AC sine wave and how we can extract data if we are given a wave formula or a diagram of the wave.